In example 3, we have what's called a double triangle question. So we're asked here to solve for the length of BC, which I'm going to label here as x. And you can notice that in this right triangle, I have an angle but no side lengths. So I'm not actually able to directly solve for the length of BC. But I do notice that the length BD is a shared side between two right triangles. And so I can use the information, the 26-degree angle and the length of the hypotenuse to solve for the shared side, which will then give me the information to solve for the side that I want. So in these double triangle questions, you're often going to be solving for the shared side first and using that information to solve for a side length or an angle in the second part of the triangle. Okay, so I'm going to start. I want to solve for the shared side length, which I'm going to label as just y for convenience. And so here I want to know the opposite side length, and I have the length of the hypotenuse. So I'm going to be using sine because that has the opposite and hypotenuse in it. And so this will be sine 26 degrees is opposite y over the length of the hypotenuse, 22.9. And so the length of that opposite side should be 22.9 multiplied by sine 26. And that turns out to be 10.038699. And I'm using a couple extra decimal places here, even though the question asks me to round to the nearest tenth of a centimeter. I'm going to need to use this value in another calculation. So I don't want to round my answer until the final solution. So next, I now know the opposite side length, and I want to learn the hypotenuse. The length BC is the hypotenuse of the second triangle. So again, I'm going to need to use sine, and so this time sine of 49 degrees should be the opposite, which is 10.038699, divided by the length of the hypotenuse. And so when I rearrange this equation, I should get something like this, which turns out to be about 13.3, and I'm going to round my final answer.